Okay, so these are some video solutions to quiz 6. And once again, I apologize for the fuzzy typesetting here from the document camera. But you're meant to go ahead and print off quiz 6 from our class website. Or better yet, have your own quiz 6 in front of you as you go through this. So we'll just run through all the solutions and see how we do. All right, so for the first one, we're going to need some areas, right? So this is our function v of t, our velocity function, and we want to find some positions for this. So let's just go ahead and figure out what all these values are here, these areas. And so this is a triangle that's 1 by 1, and so the area here is 1/2. And this is 1/4 of a circle of radius 1. So the area, remember, of a circle is pi r squared. So in this case, r is just 1, so the area is pi for the full circle. And so for a quarter circle, this would be pi over 4. Good. Similarly, this is a 1 by 1 triangle, so that area is 1/2. Then this is a 1 by 1 rectangle, so that's an area of 1, and that's an area of 1/2. And now this is half of a circle, so the full thing is going to be pi over 2. By the way, this is going to be pi over 4 on this side and pi over 4 on that side. Good. Okay, I think we're ready to answer some questions then. At time 2, the area or the distance traveled is 1/2 plus pi over 4. So that's going to be our position at time 2, our distance for time 2. Good. How about at time 4? At time 4, the position function is going to be pi over 4 plus 1/2 minus 1/2 minus 1. So the 1/2s will cancel, and you end up with pi fourths minus 1. Okay, and then at time equals 6, the position function, well, you could start at time 4, right? And then you subtract 1/2 more and add pi fourths more. So that's going to be subtract 1 and add pi fourths. So that's going to be pi over 2 minus 3/2. Okay. So if s is the position function, what is the value of s of 5 minus s of 2? Well, remember, this is the change in displacement, right, from time 5 to time 2. So if we start at time 2 and we end at time 5, right, what should it be? Minus 2. Right, because we're starting at time 2 and ending at time 5. That's what that means. Okay, so on what time interval is the position function increasing? Well, the s of t is increasing means that v of t is greater than 0, right? So we look to see where our velocity function is positive. That's between 0 and 2 and 5 and 7. So 0 to 2. Really, we shouldn't really include those endpoints, but I didn't count it off if you did. Okay, and now at which points does the function s of t achieve a local max? A local max means that our derivative is changing from positive to negative, right? Oh, wait a minute. Hang on. Sorry, something came up for a second. Okay, so local max means, yes, we're changing from positive to negative. So this is the only place where we're changing from positive to negative, right? At time 2. At time 7, notice we don't know that we keep going like this. And remember that an endpoint does not represent a local max. And so the only interior point here that changes from a velocity that's positive to a velocity that's negative is going to be at time 2. So at time equals 2, we have the only local max. Good. All right. Now, let's just go ahead and work these out. If you only have a 3 here, this means this is 3 plus 3 plus 3 plus 3. For each k value, you just put down a 3. Here we have 1, 2, 4, 8, 16, 32. This one was on our practice sheet, and so this is actually the powers of 2, and so it's going to be 2 to the k power. So this is 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5. Notice that these aren't the even numbers, right? Because you're missing 6, and then you're missing 10 and 12, and 14. And so you're missing a few of the even numbers. That's why you can't just say it's 2 times k. Okay, and I think most people got the next one. We're just plugging in the numbers here. So this is going to be minus 1 times 3 squared plus 1 times 4 squared plus minus 1 times 5 squared. And then when you stop at 6, right? And so you would stop there. Okay, and then the bottom one here is also one that was on our practice problem sheet. And so that's just k equals 1 to 10 k over k plus 1. Good. All right. Now we have a table of values, and we want to estimate the total distance traveled on this. And this is one we did in class as well. If you're using midpoints and you only have 3 subintervals, right? Where are your 3 subintervals? Well, it's going to go from here to here, and then from here to here, and then from here to here. And so you see that the midpoints are going to be at 0.3, 0.9, and 1.5. And then the widths are going to be 0.6. And so our widths are 0.6. And then the heights at the midpoint are going to be 88 plus 59 plus 19. Good. And so that's the sum unevaluated. Good. Now if we're using 6 rectangles, we have to use all of the data, right? So for L6, those are the left endpoints. So the left endpoints are 0, 0.3, 0.6, 0.9, 1.2, and 1.5. So we don't use 1.8. R, on the other hand, uses 0.3 through 1.8. Okay. So, and each of those, by the way, has a width of 0.3. So for L6, it's just going to be 0.3, and then we just sum the y values from 100 here to 19. So it's 100 plus 88 plus 74 plus 59 plus 40 plus 19. And then R6 is going to be 0.3. Now we don't use 100, but we do use 0. So we go from 88 down, 88 plus 74 plus 59 plus 40 plus 19 plus 0. Good. That's it. All right. So on this one, we've got x squared on the interval from 2 to 4. So you might just sketch a little graph of that. So here's 2 and here's 4. And we're going to use our rectangles. We're going to use 4 rectangles. 1, 2, 3, 4. Okay. And we're going to use right points for our heights. And so you can automatically see, right, that this is going to be an overestimate. Okay. So our delta x here is 4 minus 2 over 4. And so that's 2 over 4, which is 1/2. What are the endpoints going to be? X0 is 2. X1 is 2.5, right, because you add 0.5. X3 is 2.5 plus 0.5, so that's 3. X4 is 3.5, 0, 1, 2. That's supposed to be a 2 and a 3. And then the X4 is a 4. Good. So with these values, right, now we can write down our sum for R4, right, because that's going to start at 2.5 and end at 4. So it's 2.5 squared plus 3 squared plus 3.5 squared plus 4 squared. Good. That's it. And last page. Let's see. So we have some, in this case, we have some numerical values, and we want to see if we can evaluate these. So this is the integral from 0 to 10 and 0 to 6, right? So the integral from 10 to 0 is going to be minus the integral from 0 to 10. So that's going to be minus 8. From 0 to 10, 2 times f of x is 2 times the integral from 0 to 10. So 2 times 8 is 16. Now from 6 to 10, you might notice that that's 0 to 10 minus 0 to 6, right? That leaves you with the area from 6 to 10. And so this is going to be 8 minus 5, which is 3. Good. All right. This is going to be x cubed minus x squared. Then evaluate that from minus 1 to 1. I'll leave the evaluations to you. Let's see, this is going to be the integral from 1 to 3. I've got to do some algebra here first. That's going to be x minus 1 dx, so that's 1/2 x squared minus x from 1 to 3. Okay. This is x to the 1/2 power. So let's go ahead and write that first. And so that's going to be, when I take the antiderivative, that's going to be x to the 3/2 because I add 1 to the exponent. And then multiply by 2/3, and then evaluate that from 1 to 4. Okay, so I'm assuming that you can do these evaluations. So if you can't, let me know. And then finally, this is just going to be the sign of x evaluated from 0 to pi over 2. And so you end up with a 1. Good. All right, that's it. Those are the 3 quizzes. I think that's it, right? So if you do have questions on anything, let me know. Otherwise, I'll see you at the final.